Hi, everyone. I would like to welcome you to the second Better Bricks webinar of the year, The Value of Strategic Sequencing. I'm Britt Cutsforth-Dawkins. I lead marketing at the Northwest Energy Efficiency Alliance, or NEA. So I'll give a quick overview of what NEA does and what Better Bricks does, and then we'll get going into the content. For those of you unfamiliar with NEA, we are a nonprofit organization that works to drive market transformation through the acceleration and adoption of energy efficient products, services, and practices. We are an alliance of about 140 utilities and energy efficiency organizations. We work on behalf of 13 million energy customers across the Pacific Northwest. I would encourage you to learn more about NEA at neea.org. Better Bricks is NEA's one of our initiatives. It's our commercial buildings initiative that brings together energy efficient technologies, practices, things that are relevant to commercial buildings. And Better Bricks is really the centralized home for all of those resources that we've built, developed, or collected to help commercial building professionals use energy efficiency to get a competitive edge in the market. So we serve building owners, property managers, building operators, facility staff, architects, designers, engineers, contractors. Basically, if you design, build, manage, or operate a commercial building, Better Bricks has the tools and resources you need to incorporate efficiency into your building and bring those benefits to your business. So you can find all of that content at betterbricks.com. We are also on LinkedIn, YouTube. You can sign up for our newsletter at betterbricks.com/newsletter. But as I mentioned, this is the second Better Bricks webinar in 2024. We have more to come. We're looking at topics like building upgrades, financing projects, all sorts of ideas related to commercial buildings. Today, we're focusing on the value of strategic sequencing. And with that, I will turn it over to Heather. Thank you.
Fantastic. Thank you, Britt. And I'm sorry I didn't go through your slides as you were presenting
That's okay.
that.
No problem.
Hi, I'm Heather Burpee, and I'm faculty at the University of Washington in the Department of Architecture, and I co-direct the Integrated Design Lab with Chris Meek. And today I'll be getting us started off, and then I'll hand it over to Chris and Mike, and they'll introduce themselves as they get started on their presentation. So today we're going to be talking about the market context, about building upgrades and renewal, sequencing of upgrades, and some example projects. So I'm just going to get started with the market context piece. We're in a time where there are a lot of regulatory changes happening, and that's with statutes, codes, energy codes have been quickly evolving and dialing down on the efficiency of what is allowed to be built. And then ordinances, and I'm going to mostly be talking about these ordinances. And in addition to that, we are also seeing a lot of policy changes, and some of these are mandatory and some of them are voluntary, but there's a lot of policy around efficiency and decarbonization as well. And of course, overlaying all of this is some uncertainty in the market, and I'll talk a little bit about that as we go forward. So thinking about some of these statutes that are coming into place, there are building energy performance standards that are becoming more prevalent, and especially in the Pacific Northwest, in Oregon and Washington, we have these building energy performance standards. This map is put together by the Institute of Market Transformation, and they actually put this map together or update it fairly regularly. So you can see cities and states that have passed building performance standards, and then states and cities that are committed to the passage. So you can see that in the Pacific Northwest, we're one of few that have the whole state has one of these performance standards. And then within our states, cities also have their own, which means that there are two standards to have to follow for existing buildings. So I'm going to talk a little bit about the Washington, the Oregon, and the Seattle building performance standards. They're all called a little different things, but first we're going to start with the Washington Clean Buildings Act. So this became official at the end of 2020, so it's been with us for a while, and it's really coming to realization really quickly. it's a tiered program where the bigger buildings have to comply first, and then it tiers to smaller and smaller buildings greater than 50,000 square feet. So still pretty big buildings, but depending on how big the building is, it depends what the compliance pathway timeline is. And there are really three parts to this. There's a performance piece, and that means you have to meet a target EUI. And I just want to zoom out for a second. I mentioned it a couple of times, but just to say that this is for existing buildings. So any building that's operational on the ground has to comply with this standard. For new construction, they're building energy codes. So we're talking about everything that's existing. So if a building's in design right now and is built and constructed and opens, then it will then have to comply with this. So it's something that both designers are thinking about, but mostly building owners and operators are thinking about. So these three parts, the building must meet a target EUI. It must have an energy management plan to monitor energy consumption, and then an operation and maintenance plan. So what this looks like is on the right here is just a very small excerpt from the building from the act and from the regulation. It's based on ASHRAE 100, but with some localization, and it has a target EUI. So this is all about energy. And you can see the example that was pulled is healthcare here. And it has different EUIs for the climate zones, both on the east side of the mountains and on the west side of the mountains. In this example, it's the same. But for this outpatient clinic, for example, you can see the EUI is a little different depending on where the building is. So this would be the EUI target for this type of building. So the path to this is submitting documentation to the Department of Commerce, and then meeting the target EUI for 12 months, or if you don't meet it, performing a level 2 audit. And once you've done the level 2 audit, implementing the cost-effective energy efficient measures. And there is we talk about carrots and sticks, and this is really, there is a stick here where if you don't meet the target, there is a fee that is assessed, and this will be every 5 years for non-compliance. This fee is assessed, and it depends on how off you are from the target and what kind of building, but between 20 cents and $1.50 per square foot. Oregon has a similar statute, again, a tiered program. It's newer. It was signed into law in 2023 and just finished the rulemaking. And again, it's modeled on ASHRAE Standard 100, requires benchmarking EUI, and there are penalties again. This is a stick. And on the right, you can see, again, there are different tiers of buildings depending on how big they are. The bigger buildings go first, the smaller buildings go next. And here it's to 20,000 square feet. And then Seattle specifically has an additional building performance standard. And this, to differentiate it from the Washington building performance standard, this is actually an emissions performance standard. And its acronym is BEPS. So we're all talking about BEPS here in Seattle. And this is based on greenhouse gas. So this is an emission standards, not agnostic of fuel. So it looks at what the emission is of the fuel that's in the building. And the goal is eventually to net zero. And you can see that Seattle City Light, this is looking at different greenhouse gas emissions factors for different types of energy. So electricity from Seattle City Light has a very low emission. So essentially, this is going towards all electric buildings. And again, there are different paths to compliance. So one of the takeaways from this is, depending on where a building is, looking at the compliance pathways, they're all a little different and nuanced. And here there are different paths to getting to compliance, including extenuating circumstances. So there will be some exceptions. The penalty here is high. So for most buildings, it's $3.33 per square foot for non-compliance. So that will add up quite quickly. So I just want to end my section with a little note on, we have potentially an opportunity, or we might see it as like an uncertainty about with the commercial real estate market. These vacancy rates are commercial office vacancy rates in different areas across the Pacific Northwest. And we see a pattern where the more urban areas, the more centralized business districts have quite a high vacancy rate. And the smaller towns are lower vacancy rates, but some of them are within that jurisdiction are increasing. And we could see this as, the uncertainty of how owners are investing money, and it could be a downside. It could also be an upside, an opportunity where if a building is somewhat vacant, it could be a good opportunity for a deep retrofit, because the kind of moving tenants around and having to execute work while doing construction work becomes less difficult. So I think it's an important overlay, and no one has a crystal ball about what this means, but it's an important context right now. So with that, I'm going to hand it over to Chris, who's going to talk about strategic sequencing.
Thanks for that context, Heather. And again, I'm Chris Meek. I'm a faculty member in the Department of Architecture at the University of Washington, where I work with Heather. And I'm going to talk a little bit about integrated design for right sizing and load reduction. And this really builds on nearly 20 years of work that has been done in partnership with NIA and others, Mike Hatton and Solarc Energy Group, and a university-based lab network that spans the Pacific Northwest from Boise to Eugene and Portland and Seattle and WSU and Montana State. And one of our ideas is the idea of integrated design, and we've applied that to new construction and also to the idea of thinking about existing buildings and how you create synergistic effects to end up make an investment in a building and end up with a building that is better that's greater than the sum of its parts. So I'm going to just quote this as a customized technical approach for building modernization that significantly improves building energy performance, revitalizes its market position, and increases its asset value. So we're looking at experience, we're looking at economics, and we're looking at energy and energy efficiency. So let's go to the next slide. We think of this as an integrated, holistic approach of strategic building investments that add value. And I'm going to talk a little bit about how we like to think about integrated design for building renewal as a structured package of energy efficiency measures that work together in ways that are self-reinforcing, and that they deliver significantly improved energy performance, but maybe more importantly, provide non-energy benefits and are bundled with non-energy benefits that improve a building asset value. So let's go to the next slide. The concept of integrated design is an important one for me thinking about architecture, me thinking about buildings, and really energy efficiency in that context. And when we talk about integrated design, this is an idea where we're synthesizing opportunities from the climate, and that might be things like the use of daylighting to replace electric lighting. It might be the use of passive cooling to pre-cool a building, or to use nighttime temperatures to ventilate a space with either natural or active ventilation of the building. It might mean creating comfort and creating quality with spaces that are connected to the outside with windows, and shading buildings to reduce loads in other ways. And so looking at natural systems as your first source for delivering comfort in a building, and then making investments in the envelope and other aspects of the building to deliver those. And then coming in and right-sizing building systems around those natural resources that happen. And so ultimately what integrated design is a search for synergies that deliver a great qualitative experience, a lower energy demand on the building, and efficient systems that meet those demands to ensure that you deliver the highest occupant experience. So Heather, let's go to the next slide. And one of the things about buildings, all of you in the real estate industry understand this, but that a building requires constant investment to retain its market position. So over the first 10 years of its life in the graph here, we see the building sitting comfortably in Class A status. But in its second 10 years of life, we see it starting to drift downward as new buildings, shiny new objects appear on the market and become its competition and change its market position. And then in the last 30 years of this initial 30-year time period, we see the building without significant investment starting to see a significant depreciation curve, both in its asset value and its position in the market. And I'm calling that the cost of doing nothing. And ultimately, wise building owners make investments to maintain their building's market position. And we think through integrated design in the building renewal process that those investments can yield a building not just that retains its position, but that improves it and delivers a higher quality building at the end of a life cycle. So we're looking to add value by aligning our investments with the existing building life cycle to build upon and reinforce one another. We're also looking at integrated design measure packages that we map out over time, thinking about the life cycle of the building and when do we make certain investments. This is the strategic sequencing piece. When do we make certain investments? At what point do systems need to be replaced? And what investments can be made upfront that maybe decrease investments down the road in terms of cost and deliver higher value in that context. So Heather, let's go to the next slide here. Implicit in all of the things that I'm saying is improved ROI for your building. And one of the things that I think is becoming more and more understood and more and increasingly quantifiable is the return on investment of high performance design. And Heather, myself, and others partnered with the American Institute of Architects to do essentially a literature search on evidence-based quantitative documentation of investments in high performance building and how those return value to the owner and the stakeholders in the building. And this includes things like improved health, improved productivity, resilience, codes and coming up to codes and standards, and a whole host of other things. And the link is provided down in the lower right here. If you're interested in arguments for why high performance building design should be part of your building renewal and integrated with it, this provides a great starting point for lots of dimensions of that equation. So let's go to the next slide. When thinking about sequencing building upgrades, we have a whole host of measures here that apply to a broad subsection of building typologies. And we've kind of structured them in this case in the order in which they have increasing synergistic impact on the downstream measures. So we start with operations and maintenance, the kind of things that make your building run right. Then move into envelope, the kind of things that reduce loads. For example, better envelope sealing to reduce infiltration, or better windows to reduce unwanted heat gains and losses, or to provide shading and load reduction of various flavors. Then looking at lighting and how those can reduce your cooling load or save electrical energy in various ways through controls and other technologies. Then plug loads, how you might engage your tenants or your own staff in contributing to reduced loads through better procurement practices that incorporate things like understanding the energy use of equipment that you bring into your building. And once we've gone through those measures, which all have the opportunity to reduce the loads that are imposed on the building systems, we start looking at building level HVAC. That's equipment that's in the suite, in a VAV type system or another mechanical type system. You'll have terminal type units, and then looking at plant HVAC and how big our plant needs to be, or what type of central plant equipment we might use. And then once we've done that, looking at maximizing efficiency through advanced controls technology. So that sequentially provides what we think is generally the optimum approach. And in all buildings, these opportunities are going to be different based on the expected lifespan of various technologies. And ultimately, in most long-lived buildings, these pieces of equipment will be replaced, modernized, modified, upgraded at some point, and strategically making these upgrades is going to give you a better building at the same cost at the end of the life cycle period that you're looking at. So let's go to the next slide. Few key technologies that we might use here are better windows or window retrofit attachments that might come into play and be applicable in your building. Looking at better lighting, better shading, plug load management of various flavors, either through controls or through settings on equipment that is brought into the space. And then bringing tenants into the equation. Increasingly, tenants expect to be in high performance buildings, be in low carbon emitting buildings, and more tenants want to be involved in that process and feel engaged in being part of the energy efficiency equation in a building. So let's go to the next slide. And did we skip one? I'm going to touch on this just very, very briefly. This is just, and Mike's going to get into this in more detail after I'm finished here, but looking at the difference between a load, loads on a central plant. In the first case with the black dots showing the loads that are imposed on this building prior to load reduction. And then our second chart here, this is over the course of the year, this is cooling loads in tons being significantly reduced, meaning that you can buy smaller equipment. You can use less space for that equipment. You can use less energy. And perhaps you can move to alternative energy type systems that maybe are all electric, or maybe are delivering more comfort, or are smaller, or free up space. There's all kinds of building repositioning opportunities embedded in this fairly dry mathematical diagram here. So let's go to the next slide. Couple things that are important takeaways is when should I do this? And I think every building owner should have a strategic roadmap for how their building goes through its life cycle and where it lands. And we don't want to do a building where we replace like for like, and 50 years down the line we have a 50-year-old building that is exactly like it was or near where it was at its inception. We want a building that is substantially better or equivalent to a contemporary building at the end of that 50-year investment life cycle. And opportunities to make those investments are, if you've planned to make those investments, that's a great one. That's the first one. That's the no-brainer. And then thinking about equipment that is approaching the end of its service life. So you're building resilience and making sure you replace that equipment prior to catastrophic failures or other situations that are going to be upsetting to the tenants or others. And then if your building is significantly underperforming the market, this is an opportunity to make an investment. I'm happened to be at the Urban Land Institute meeting in New York this week, and the buzzword across the board is a flight to quality. and that buildings of high quality that are perceived as high quality in the market are doing really, really well, and that investments in existing facilities are a way to reposition buildings into their desired market performance. So also thinking about changes of use, new major tenants, envelope improvements are a great opportunity to improve building performance. And then replacing outdated systems such as lighting and HVAC, aesthetic upgrades, and building energy use that doesn't look like it's peer buildings, right? It's an outlier on the negative side. And then increasingly, we are seeing people make investments because they want to meet building performance standards. Heather talked a lot about that. And there's the cost associated with not meeting the building performance standard, right? This is direct cost. But there's also the cost of the stigma of not being able to attract tenants because they don't want to be in a building that is seen as one that's not doing its part. So with that, let's go to the next slide. Better Bricks has a number of resources that are targeted toward things like lighting, an entire program on luminaire level lighting controls, which is a great retrofit tool that is non-invasive and delivers all kinds of energy and non-energy benefits to tenants who want new and improved lighting with higher levels of granular control. So there's some links to that resource here. And then higher performance HVAC. Nia and Better Bricks has done a lot of work looking at very high efficiency dedicated outside air systems that are incredibly efficient and deliver high quality indoor environment through 100% outside air. So that resource is linked here too. And then there's a whole section on building renewal articles that provide inspiration and guidance to building retrofit. So briefly, I want to touch on a case study that takes us through this sequencing idea. And this is a multifamily residential building, a small apartment building owned by the Seattle Housing Authority. So this is a resource-constrained client or building owner looking at a number of goals. So let's go to the next slide. The first one being that this building is underperforming its peer buildings in terms of its energy use. It's currently at an EUI of about 43, and it is required by the state building standard to meet an EUI of 32, which is a pretty big move. It's well outside the 75th percentile for its building energy use. So let's go to the next slide. So their goal is to meet the EUI of 32 kBTU per square foot year with its energy performance. But maybe more importantly is that they have significant comfort issues. These are elderly, these are vulnerable populations often in these in this facility. And when we have excessive heat, it currently doesn't have any interior cooling, except for one small cooling center in the middle of the building. They move their tenants onto a bus and bring them to public libraries or other gymnasia that are cooled at cooling centers. And they don't want to have to rely on that for cooling because it's it disadvantages their users. So they're looking to improve the comfort and health through their building renewal. So if we go to a strategic assessment and this sort of like comprehensive pathway or sequence, we see a couple things. Measure 1 and 2 at the top here are improve the envelope through better windows and through reduced infiltration. So that's the foundational moves that this entire set of packages rests upon. That's the load reduction piece that allows us some opportunities to get to 32 kBTU per square foot year through a couple of different pathways that each offer opportunities and maybe some costs. So let's go to the next slide. The first pathway is to simply provide each unit with ERVs or energy recovery ventilation, which reduces the cooling demand on the space. Reduces the heating demand on the space. And we modeled that if we put energy recovery ventilation after providing improved windows and reduced infiltration, we could get to 32 kBTU per square foot year with just adding a little bit of the insulation to the wall and adding a heat pump domestic hot water heater to each unit. And let's go to the next slide. The advantages of this is that we are now providing 100% filtered outside air into the apartments, which is nice during our smoke week in Seattle, at least, and that improves the indoor air quality in the space, and it's a significantly lower cost than heat pumps. The downside is we have to change the ERVs filters regularly. We have to add some ductwork, and we don't get the benefit of cooling because we haven't added the cooling capability that a heat pump provides. So if we go and look at the other pathway, we see that we make this envelope investment, we make the window investment, and then we add heat pumps to the space. We can also get to that 32 kBTU per square foot year by providing ductless heat pumps in these units. So if we go to the next slide, what we see is we get space cooling, which provides improved thermal comfort in the summer. We get great energy use, and we have a little bit more cost. And we've got to find a way to locate the outdoor units associated with the heat pump equipment. And if we go to the last slide, so this is the work that we did understanding these pathways was part of a simulation-based exercise to find the lowest cost pathway to an EUI of 32 and to meet various comfort requirements of the occupants. And they're rolling this out to the various types of buildings that they have, sort of small apartments, quadplexes, and duplexes, and using integrated design and strategic sequencing to get the best value out of their investments in these, both for human comfort and for energy efficiency. And with that, I'm going to pass it over to Mike.
Before Mike comes on, I just want to jump in to say that I meant to say when I handed it off to Chris, but I'm glad he mentioned that Better Bricks has a lot of really great resources for some of the things we're talking about today. And we recognize that we're diving pretty deep into the weeds. And if you're just getting started, and this is like just a lot, the resources at Better Bricks are a fantastic starting point. So we'll circle back to that at the end too and have the URLs for those. But I just want to mention that you know, we're diving deep so that you can see kind of the tactical when you get there, but know that, you know, there are higher level resources that can help you get started if you are just starting on this journey. So with that, we'll go into some more tactical details with Mike. So Mike, why don't you introduce yourself and take us away?
Thank you, Heather. So my name is Mike Hatton. I am a mechanical engineer and longtime energy engineer with Solarc Energy Group. As Chris mentioned, I've been working with the Integrated Design Labs really since their beginning, and I've spent over 40 years of a professional career working in various roles on building energy retrofits. That has been my focus. So as an energy analyst, as design engineer, as contractor, I've worn all those hats. And so what I'm going to do is give a fairly high level overview on two projects that I've had specific involvement with, and maybe give you a slightly different perspective than what Chris has just run through. I would definitely characterize these as real world. They don't necessarily fit neatly into every piece of the strategic sequencing, but I think, and hopefully everyone will agree, the outcomes and the results have been, would check all the boxes of success. And so we'll start with, this is a large state office building located actually in Salt Lake City, owned and operated by the state of Utah. This project is complete as a building energy retrofit, and actually it's a relatively new building. It was constructed in 2009, and interestingly was the first building designed under the then new and now current state of Utah high performance building standards. It's about 265,000 square feet, and this building renewal project was completed in 2017. The project driver here I reference as Owner Energy Initiative, but really this was a building whose energy performance was higher than its peer buildings, if we want to reference back to some of the opportunities on one of Chris's slides. And the primary strategy here was a whole series of operations and maintenance moves, or what I'm calling recommissioning moves, touching on a lot of the existing building systems, from the HVAC systems to the potable hot water systems to the central plant systems. And I would characterize this building, I think you'll see, as a building that had all the opportunities available to it for potential high performance, but had a number of operational deficiencies that needed to be addressed. And so Heather, if you would go to the next slide. One interesting aspect of this building is that these energy savings that we're going to go through are actual verified meter-based savings. And so what we saw on the electricity side for that whole series of recommissioning moves was a 23% reduction in whole building energy use. That translated to just over 581,000 kilowatt hours a year. And in 2017, that was worth $33,500 per year. If you go to the next slide, Heather, we'll see on the fossil fuel side, we really overachieved. So almost a 70% reduction in natural gas energy use in this building, translating to just under 54,000 therms per year and worth just under $40,000 per year. You'd go to the next slide. We can look at the overall whole building or whole project performance here. Now, in first bullet under the summary, cost to implement, under $10,000. So this is a stake in the ground on one type of building energy retrofit project, O&M focused. Work was done almost entirely by state building staff, and there were almost no new materials purchased to implement this project. Interestingly enough, the electric utility incentives were almost $13,000, well over the cost to implement, as this project was participating in a recommissioning incentive program where there was no cost caps and remains no cost caps. Total utility cost savings, $73,400. This return on investment is instantaneous. Our EUI reduction, as EUIs are of interest, I think, in many of these building retrofit projects, we saw an EUI reduction of 31.5 kBtu per square foot. That's a 48% overall reduction in savings. Our starting EUI was 64.9. Our ending EUI was 33.4. Interestingly enough, energy modeling had to be done as part of the high performance building design standards, and that model predicted an EUI of 36. So the model was right, the operations were wrong in this building, and got corrected. So what we saw on the non-energy benefit side was significantly improved occupant comfort, and particularly relevant was the improvement in acoustical privacy in the meeting rooms that were subjected to some return air duct modifications, and allowed them to actually close doors when there was a public meeting occurring in the meeting room. We also saw significantly reduced operating and maintenance costs, particularly associated with the ongoing failure of heat exchangers in their condensing boilers. They were losing a heat exchanger every 1 to 2 years because of deficiencies in the heating water system at a cost of about $20,000 per heat exchanger. That is no longer happening. So if you go to the last slide, I just want to review, or go to the next slide, thank you. The project process, and this is where I would say these example projects follow some level of strategic sequencing, maybe their own flavor, but we started with a utility initiated energy assessment and maintained involvement both at the local building level and at the state system level. The improvements were identified and implemented in an incremental manner. We adopted a work session, what I call the work session model, and took 6 months to incrementally implement the improvements, identify and implement over a 6-month period. This is an example of one of the reports that came out after one of the work sessions. During the implementation period, we started tracking savings using before and after meter information. And then we concluded the project with a verification report, a formal closeout, and delivered a savings persistence plan to the owner. If you go to the next slide. So our last example project this morning is a acute care hospital operated and owned by Providence Health and Services in Walla Walla, Washington. This, interestingly enough, is a project that is being driven by a need to comply with the Washington State Clean Buildings Act. And actually, Heather had a slide up that showed the target EUI for a facility of this sort. It's about a 400,000 square foot acute care hospital, and needs to achieve a target energy use intensity number of 215 kBtu per square foot. Currently, and this has been a fairly stable EUI, actually over the last 4 or 5 years, they are running at an EUI of 245. So a minimum EUI reduction target for this project of 30 kBtu per square foot year. This project is ongoing right now, and its primary strategy has been a focus on HVAC control. So going all the way to the bottom of Chris's table is where this owner decided to make their next move to comply with the Washington State Clean Buildings Act. And that HVAC controls upgrade includes replacing the remaining pneumatic controls infrastructure with modern digital controls. This project was actually started over 10 years ago and got about 2/3 of the way through the hospital, and then stopped. So they are committing to finishing that controls modernization project and then layering on a comprehensive rebalancing for the entire airside building HVAC system, as well as converting the remaining constant volume elements in the system to variable air volume functionality. So if you would go to the next slide, Heather. We'll talk about the modeled and calculated savings. So these savings are projected. They are just starting construction on the controls project now. On the electric side, we're projecting 6% reduction in whole building use, but that's an 11% reduction in the relevant energy HVAC electrical end uses that you can see circled there: cooling, pumps, and fans. Totals over 633,000 kilowatt hours, translating to about $46,000 per year in reduced electrical costs. If you go to the next slide, we can see an emergent theme here where we're performing relative to electricity on the fossil fuel side. We're projecting a 37% reduction in whole building use, over 166,000 therms of natural gas per year, worth of just under $81,000 per year. So let's go to the next slide and we'll take a look at the project energy performance. This is a capital project. Our projected first cost is $1.2 million to implement. We do have an electric utility incentive on the table of worth about $96,000. Utility cost savings is $127,000 annually. Very interesting, however, is if we start accounting for the avoided penalty associated with the Washington State Buildings Act. For this facility could be over $450,000 assessed every 5 years, assuming that they would be assessed the maximum penalty for noncompliance. If we deduct both the utility incentive and the avoided penalty from the gross cost, we have a net cost of just over $650,000 and a simple payback return on investment to the owner of 5.1 years. The EUI reduction is targeted at 50 kBtu per square foot year, so well above the minimum target. That represents a 21% reduction in overall EUI from 245 now down to 195 after this project is done. And we do expect significant non-energy benefits, primarily related to improved operating and maintenance time and effort as we take the remaining 30% of the building that is essentially invisible in terms of its operating conditions and make those visible through the computer interface associated with the new controls project. And so I'll just conclude with just a process slide on the next slide, Heather. And you should see some similarities here. This project started with an owner-initiated level 2 energy audit. The owner hired, in this case, myself, to conduct the level 2 energy audit. We were able to maintain significant engagement with both local and system level technical staff. And they have now moved into the implementation phase, and Providence is using a design build project implementation approach. We are going to maintain review roles, and there will be a coordinated utility incentive application associated with this project. And before I turn this back to Heather for wrap up and discussion, I would just like to point out a few themes that I think are cross-cutting here. And one is that every one of these building retrofit and renewal projects, I think, is unique. And it's responsive to the needs of the existing building. We have an existing building, we can assess their needs, and that's the second cross-cutting theme, is that every one of these projects seems to want to start with some level of building assessment to identify those needs and to identify points of intervention and prioritize a set of improvements. And then finally, an expectation on outcomes. I think we're seeing in all of these projects, we expect consequential and meaningful reduction in building energy use. And we expect a meaningful and important set of non-energy related outcomes as well. With that, I will return control to Heather.
Thank you, Mike. I think it's always really helpful and inspiring to see real projects. And I especially appreciate seeing the data to show like this is what we expect or this is what we're seeing in terms of the real kilowatt hour and therms savings over time. I think there's nothing more gratifying than seeing progress on the actual numbers from my perspective. So just to wrap up here, and I'm looking forward to hearing some questions from the audience, and feel free to type them in the chat, or we'll come back to have you come on camera and or jump in and ask any questions. But I want to circle back to these Better Bricks resources. You know, we talked about several specific examples, getting to the real tactical and the data. But if you're just getting started on this journey and or diving deep, the resources on Better Bricks are a really great place to go to find both that high level, where do we even start, what are we talking about here, to then different technologies that can help meet some of these efficiency and building performance standard goals. So with that, I think I'd like to open it up for questions and or comments. And as you think about your question and I leave the silence, I'm going to put our pictures up here, mostly because our email addresses are here. So you're welcome to reach out to us directly as well. Thank you all.
Hey, Heather, I have a question. Bob Archer with Dallas School District down here in Oregon. With the energy performance, like I know we work a lot with Energy Trust for lighting upgrades and whatnot, but I mean, it's funding with schools are that's the biggest thing, that we're facing not only unfunded mandates for building performance, energy, lighting, but with many other aspects through education as well. Are you all aware of any funding sources, grants, or avenues that school districts specifically could pursue to help, aid in some of this?
Yeah, I think it's a really great question and comment. I think just to acknowledge there are a lot of pulling forces right now on finances, and schools are like at the crux of that, right? So to more directly answer your question, the utilities, depending on, I'm not familiar exactly with your utility, but utilities often have incentives for energy efficiency. There are also programs, like for example, the Washington Department of Commerce has funding for some of these implementation for some types of buildings, and it's mostly for those that are under served or groups that otherwise would have difficulty securing funding. Another huge resource right now is that the IRA and the federal funding that's coming through. It's quite complex, and it's really a tax incentive more than a direct incentive. And I'm curious Chris's answer to this too, but I think that we've been advised that having somebody that is a tax expert and or a funding expert is a helpful person to have on your team, because it is quite a complex landscape right now, and there are a lot of opportunities, but they're very specific to what kind of ownership and population you're serving. I also know that there will be a forthcoming Better Bricks webinar on financing. I'm not sure, Britt might know when that is, but I know that it's coming around the corner this year. So that might be an interesting one to listen to as well. Chris, I don't know if you want to add to that at all, or
maybe I would ask Mike, who has lots of experience in Oregon, lots of experience with ETO, and lots of experience with high performance schools, to maybe weigh in before I do.
Just two quick comments, Bob. One is, if you haven't reached out on a whole building approach to Energy Trust, their incentives are at the historic maximum right now. So if you're, if the district is ready on one or more facilities to take a whole building approach, they will cover the cost of that analysis, and their incentives I'm seeing projects right now where they're maxing out at their cap. So that's number one. Not just lighting, but a whole building approach. And then number two is to stay tuned to, as the administrative rules are being written by Oregon Department of Energy right now, they will be completed by year's end. And I fully expect we shall see whether there is something similar to what Washington State put in place, what they call their early adopters grant program. So we might see something like that, at least for folks who are getting on board early to try to modify their existing buildings that are non-compliant with the EUI standards.
there's a question in the chat. Hello, UW IDL alum. I'm curious who you are, but they have a question about the Seattle Housing Authority project, and that there's a lot of need in the affordable housing world. And how did SHA finance the improvements that you were talking about, Chris?
So I have to confess, I don't know if they took a special funding mechanism for these beyond their capital improvement budget that they had. There was work planned on this particular project that was budgeted for, and they asked us to take a second look at their scope and to see if there were ways that we could improve the value for what they were laying out in terms of cost. And so we gave them a number of pathways and did one of the nice things about working with the housing authority is that they have very comprehensive and up-to-date cost information, so that we could give them, really look at their data and help them understand what was going to deliver the best value, the best non-energy benefits, which were a driving force in addition to the state mandates that they have to comply with. But Jess, if you reach out to me, I can connect you with someone at the housing authority who could speak to if there were special grants that they got. I know they get a lot of grants, so I don't know how they structured the financing on this one, but we got them pretty close to within the budget that they had planned for their initial upgrade, and I think added some value there.
Thanks for that question. Lots of finance.
One thing I'll add is that I think where the value was added was in this strategic sequencing. So thinking about how do various measures impact others, open up opportunities for maybe lower cost or better outcome attributes at the end of the project. So it's apropos this topic. Heather, are you frozen?
No, I'm not. I'm just leaving
Oh.
some space in case anybody wants to come on. Thank you for your questions. I think there's a lot of questions about financing, and I think they're very good ones and complex, as we know. Important to hit these energy targets, and it's also important to have it fit within what works from a financial perspective. But at the end, there will be financial benefits too.
One thing I might do is just add a little bit on. Heather mentioned ARA funding, and the DOE has a number of programs, and I know it's slow getting them all out, but there are a number of funding mechanisms, technical support mechanisms to help building owners transition to higher performing, more energy efficient buildings. And I know there's a number of projects that are earmarked for specific disadvantaged communities, for example, and those are underserved urban and rural communities. I think there are some that are aimed at the K-12, supporting K-12 infrastructure and others. So that's, and I can't say I have a full view of that of all the things that are happening in that space, but there is a lot of resources coming from the federal government and specifically from DOE. So that's a really good place to look.
Yeah, that's the Inflation Reduction Act, the IRA funding. I think, thank you all for your questions. Thank you for being here. I'm going to hand it back to Britt.
Yeah, I was just going to say we have not scheduled the financing webinar yet, but that will be forthcoming. The best way to find out about that is to go to betterbricks.com/newsletter and sign up. You'll get a monthly email full of ideas about energy efficient products, services, and technologies, and notification of future webinars. So thank you very much for coming. We hope you enjoyed it. And as Heather said, all the email addresses are here if you have further follow-up questions. Thank you so much.
Bye all.